Okay, we're going to have a look at the final clip now of the low resolution spectroscopy for NMR. And as we've figured out now, we have ethanol, a non-symmetrical molecule with three individual peaks corresponding to the three different environments of the hydrogens within the molecule. Now, NMR has a few more tricks up its sleeve. Now, one of the ones that low resolution allows us to do is it actually allows us to count the individual protons in each of the environments. And it does this by looking at the area underneath the curve, and it's quite specific. Each area under the curve corresponds to a relative number of protons within the molecule. So if we start at the left-hand side, there is one hydrogen on this OH corresponding to this peak here. Okay, so that was what was established is the most electronegative environment hydrogen within the ethanol molecule, and there is one of them. What we'd done up until now is we had only drawn the peaks an arbitrary size. We hadn't taken into account any type of relative size of the peaks. However, what we do know is that the CH2 alongside it actually has two protons within that environment. And actually what we should observe is that the area under this peak here corresponding to those protons should actually be now twice the size of the OH peak. So what we would actually observe is not what we've been drawing to date, but we'd actually see a situation whereby the peak was twice as high. Now, that's strictly not true. What we would see is a peak where the area underneath the curve was twice as much as the area under the curve of the red one. Likewise, we wouldn't see the same peak over there. What we would now see is a peak 3 times bigger, but not necessarily 3 times higher, but with an area that is now 3 times bigger underneath the curve, underneath the peak. Okay, so these aren't discrete singular lines. These are actually kind of like triangles essentially, but you can measure the area underneath each of these peaks, and the measurement of the area tells you the relative number of protons in that environment. So there will be 3 protons in that environment, there will be 2 protons in that environment, and there will be just a singular 1 proton in that environment, but it tells you the relative number. Obviously, we've got ethanol as an example, so we know there's 1 proton, 2 protons, 3 protons in each of the environments, but in bigger, more complex molecules, it tells you the ratio. There may be, for example, in these numerical values, 6 protons in one, 4 in another, and 2 in another if we happen to have a bigger molecule. So what we have to do is you'll be given the integration traces within the question. They'll be given as a like curve, something like this, and what you'd have to do is measure the top to bottom, measure the distance, and then you'd see the relative integration traces for each of the peaks superimposed. Okay, so low resolution now tells us number of protons and the type of protons. We're going to move on to high resolution, which gives us even more crucial information.